If you spot the next pattern, you just, to draw the next pattern there, you just stick on a hexagon. You can see that, yeah? Or a hexagon, that's a pentagon. Stick on a pentagon. Yeah? Is that right? Are we good with that? For this one, 2 dots, then then it's 2 dots, no dots, 3 dots, 2 dots. Then there's 4, 3, 3. Okay, so what are they doing? They're adding a dot across the top and a dot down the bottom. Yeah, in the second line, aren't they? So across here there'd be 1, 2, 3, 4, 5 dots going across and 4 dots going down, yeah? And 4 dots going down in the second column, in the third and in the fourth. Do you know what I mean? They're making... adding 3 to the number they added on last time. 2, 5, 3, 6, 9, 10. There's only 5 there, so you added on 5. Okay, you can spot the pattern anyway. I'm no good at that. That's why I'm not drawing these. These, you're going 2 dots, then there's 4 dots, then there's up. Sorry, then there's 2 dots going up, then there's 4 dots going up. So I would say 8 dots going up, and then 16 dots going up. Would you say that? Yeah. Okay. Right. That's yeah, basically more the same there. Right. Okay. Is that right? I'll give you a few of the harder ones tonight just to make sure we've covered everything. Okay. So I want to move on to arithmetic sequences. Right. Sounds very. Now don't ask me why they're called, because I have this conversation with other maths teachers all the time. I don't know why you say arithmetic, but when you say sequences, everyone calls it an arithmetic sequence. I don't know why it's arithmetic and then it's arithmetic, but it's the same spelling as arithmetic. Okay, so sorry, all blown up. So arithmetic sequences, right? Okay, is the ones you did in junior cert, right? So it's a sequence where you add or subtract the same amount each time, right? So you're going up in 2s, or you're going up in 3s, or you're going down in 4s, or down in 10s, or whatever. Okay, you're adding the same amount each time, right? In junior cert, we call them linear sequences, right? Okay, but they're the same thing. And there's, I'll tell you about the tables in a minute. You need the formula. Okay, so a linear sequence and an arithmetic sequence are the exact same thing. Okay, so arithmetic sequences, right, is where a sequence where you add or subtract the same amount each time, and we used to refer to them in junior cert as linear sequences. An example would be 2, 4, 6, 8, 10, and so on. Basically, you're adding 2 each time. So you're adding 2. So that's an example of an arithmetic sequence, right? Another example would be 3, 8, 13, 18, 23. This is also an arithmetic sequence because you're adding 5 each time. So plus 5, plus 5, plus 5, etc. plus 5. Finally, it needn't be a plus number, it could be a minus number. Okay, as in we could do we could start at 25, the next term could be 21, the next one could be 17, then we 13 and 9. In this case, it's minus 4 every time. So you're adding or subtracting. Is that okay? Arithmetic sequence. You've seen them before in junior cert. We're happy enough with them? Yeah. Okay. So just a couple of facts about arithmetic sequences on the next board. Right, are we good? No. Are we good? Right, okay. So I'll leave you write it down and then I'll talk about it. Say that again. 4 and 1. Sorry, it's 4, 1. You ready for me? Right, okay, so in every arithmetic sequence, we call the first term A. So A or T1, term number 1, or the first term. We just call the first term A. Right, we'll be filling in the formula in a minute. The first term is A. So there's going to be an A in the formula there. There's the formula. There's the A. That's the first term in the sequence. So in the cases, the examples I use back here, right, A here is 2, A here is 3, A here is 25, right? So whatever the first term is in the sequence, that's what A is. Is that alright? D is the common difference, what you're adding or subtracting each time, right? Okay, so if you, to get it, you just take term 2, take away term 1. In fact, if you take any term and take away the previous term, that's what that means. Tn is any term, and Tn minus 1 is just the one right before it, right? So if you take any term and take away the previous term, you'll get the common difference, D. Is that right? So in this case, back here, right, the common difference was plus 2. Here, D was plus 5. And here, D was minus 4. Is that right? Okay. And it's normally, we normally do term 2 take away term 1, as in 4 take away 2. But you just take any random term, 8, and take away the previous term. That's what the Tn take away Tn minus 1 means. It's just jargon. It's just saying take any term, take away the previous term, and you'll find out what D is. Right? Okay, is that right? Okay, so that's what the third line means. right? If you take any term, take away the previous term, you get the common difference, right? And finally, there's a formula to get the Tn, the general rule, to get the rule, right? Or the general term, we call it. To get the general term, it's a plus n minus 1 times d. It's a formula you fill out. It's in the log tables on page 22, okay? So you don't need to remember it. I don't know if you use that in Junior Cert or not. There's two ways to get the general term for an arithmetic sequence, right? One of them is the formula. If you didn't use the formula, you have to start using it now because we need it for, there's some complicated ones that you won't be able to do without the formula. Is that right? Okay, so we have to use the formula now. Okay, there's a different way to have done it in Junior Cert, right? Probably shorter way, but we have to use the formula now. Is that right? Okay, so example 1. So in the sequence 10, what should I write, 7 was it? 10, 7, 4, 1, find Tn using the formula, right? And then hence find T20. So use your answer to find term number 20. Okay, so the sequence is 10, 7, 4, 1. So A is the first term. So A is equal to, what's A equal to? 10. D is the common difference. What are you adding or subtracting each time? So D is minus 3. You're subtracting T. You're subtracting 3. Okay, so D is minus 3. So if you're adding, D is going to be a plus number. If you're subtracting, D is a minus number. Then you have a formula. So the formula is Tn is just the general rule. A plus n minus 1 times D. Right, you're looking for the general rule. You fill in the A and the D. You don't fill in the N. Right, okay. So n is the number of term and you're just looking for the general rule. So A is 10 plus n minus 1 multiplied by minus 3. So the minus 3 is just at the end of the bracket, so you're multiplying into that bracket by minus 3. So Tn is equal to 10 multiply n by minus 3. Minus 3 by n is minus 3n, and minus 3 by minus 1 is plus 3. Okay, so Tn is equal to minus 3n plus 13, or 13 minus 3n, who cares? Is that right? Got it? Okay, will I remind you how we used to do this in Junior Cert, just so you know what we're at? You remember we used to go, right, if it's, what was it, 10, 7, 4, 1, so you're subtracting 3, so you know Tn is minus 3n plus or minus a number, so you're not sure what you add or subtract, so you check it out with term number 1. So term number 1 is everywhere I see an n, put in a 1, so it's minus 3 times 1 plus or minus what number, and you know the answer is going to be 10 because term number 1 is 10, and then you'll go minus 3 plus what number will give me 10, and the answer is 13. So it's minus 3n plus 13. I don't know which one you did in Junior Cert, right? A lot of scared faces looking there. Don't worry about this, okay? You probably used this. I don't know. Do you remember what you used? No, nothing. Let's forget that. So, right, okay, that's just confusing. Right, formula all the way. Right, it's in the log tables. You don't even need to remember it. Okay, are we all good? Right, that was part 1. Find Tn. So the general rule for that sequence is if you want to get any number term, you take the number of the term, you multiply by minus 3 and you add 13. So in part 2, they asked me to find term 20. How will I find term 20? Everywhere I see an n, it's term number 20. So n stands for the number of the term. So everywhere I see an n, put in a 20. So it's minus 3 times 20 plus 13, which is minus 60 plus 13, which is minus 47. Is that okay? We good with that? Do you need another example, just filling out the formula, or do you think it's okay? It's okay? Anyone? Okay. Right. Will I go for a harder example? So, one like higher level example. I get the board. So instead of me writing it out in the book, I'll get you to copy it out. This is example 2, and I'm just skipping on to here, and it's going to be number 6 here. So I'll just do number 6. I'll blow it up, don't worry. Right, so in an arithmetic sequence, term number 13 is 27, term number 7 is equal to 3 times term number 2. Find the expressions in terms of n for them 3, in terms of n for those 3 terms, and hence find the values of a and d. Right, write down the first 6 terms of this sequence. So we're going to end up with simultaneous equations here. Okay, right, so I'll leave you write it down and then we'll do it. Sorry? Nothing. Sorry, is it cut off? Is it alright? Yeah. Okay, are we ready? Right, so let's do it. So, okay, so they told me it's an arithmetic sequence, right? That's the first 3 words in an arithmetic sequence. So off I go to my log tables. I know this formula is going to apply. Right, okay, that's the first thing. Sorry. Okay, the second piece of information they told me was T13 equals 27. So term number 13 is 27. Okay, I can't fill in A because A is term number 1, I don't have it. I can't fill in D, I haven't a clue what it is. But what can I fill in? I can fill in term number 13. So what can I fill in? What can I fill in? N. I can put in 13 for N, can't I? So it's A plus 13 minus 1 times D. But I know when I work all that out, what's the answer going to be? 27. Because term number 13 is 27. So whatever the A and D are, when you work it out, you're going to end up with 27. So that's A plus 13 minus 1 is 12D equals 27. That's as far as I can go with that. Okay? So park it for a minute. Okay? The second piece of information they tell me is T7 equals 3 times term number 2. So I have to get 7, T7. So what will I do? Everywhere I see an N, put in a 7. So that's A plus 7 minus 1 times D, right, equals 3 times term number 2. So I get term number 2. So it's 3 times A plus 2 minus 1 times D. Great. Sorting this out, you get A plus 6D. Over this side, you get 3 into A plus 2 minus 1 is 1 times D, right? So sorting that out, A plus 6D equals 3A plus 3D. Bring everything over to the left and you'll get minus 2A plus 3D equals 0. There's my second term. Is that right? Sorry, I drew across the minus there. There's a minus there. Okay? Simultaneous equations. So A plus 12D equals 27. Actually, I'm going to multiply that by 2 as I'm writing it out. So I get 2A plus 24D equals 54. So I just multiplied that by 2, okay, because I'm jumping ahead, making life easier for myself. Then I have minus 2A plus 3D equals 0. The A's will cancel. I'll get 27D equals 54. So that means D is equal to 2. Is that right? And then take A plus 12 times 2 equals 27. So that means A plus 24 equals 27. So that means A is equal to 3. So first term is 3 and I'm adding on 2 each time. So it said write out the first 6 terms. So the first term is 3 because A is the first term. D is a common difference, means I'm adding on 2 each time. So 3, 5, 7, 9, 11, 13. Is that 6 terms yesterday's, I think. Yeah, there we go. Are we good? Okay, are we good? Right, example, what am I on to? Example 3, 4, I don't know. What's it? 4? 3. Example 3 is number 7. Okay, so you can write it down there. So it's number 7. Okay, 7 part 1. Just 7 part 1. Okay, so example 3 is 7 part 1. So just this part. had you down, sorry. I just took it off. Is it okay? Right. Okay, so there's your 3 consecutive terms. Now you don't know, are they the first term, the second term, the 9th term, the 100th term, or do you care? Right? All you know is, if you take away that term, will give you D. Agreed? The middle term, take away the term in front of it, will give you D, yeah? Okay, so D, if I take the second term, and I take away the first term, which is 2k plus 2, I will get D. Agreed? I put it into a bracket because that plus 2 will become a minus 2 because you're taking it away. So D is equal to 5k minus 3 minus 2k minus 2. So that means D would be equal to 3k minus 5. Agreed? Did I do that right? I didn't make a mistake, did I? No, I'm okay. Right? Are we good? But there's another way of getting D. Can anyone spot a second way of getting D? So D is the second term, take away the first term, say. But you could also get D from taking 6k, take away the term right before it, take away 5k minus 3. Would you agree? So that was, the second thing we wrote down, that D was Tn, take away Tn minus 1. It's any term, take away the previous term. So any term, take away the previous term will give you D. Right? Working that out, so D would be 6k minus 5k plus 3. So that means D would be equal to k plus 3. Okay? Agreed? Suggestions? I can let the two, I don't need to do simultaneous equations. If D equals this and D equals that, would they not be equal to each other? Because they're both equal to D. You know the way D is equal to this and D is equal to this. So would you all agree that D would equal to D? Right, it's a bit stupid thing to write down, but I'm just trying to explain where I'm going with this. Right, okay, so D is 3k minus 5. Right, but D, I also worked D out to be k plus 3. See what I've done? So because both equations are equal to D, they must be equal to each other. Right, then it's k's on one side, numbers on the other. So 3k minus k when it comes across is 2k. 3 plus 5 when it comes over is 8. So divide by 2, so that means k is equal to 4. And that was the question, find k. Right? A great life. I'm being interested today, I know. And we're flat out in here. Right, I was going to give you questions for the rest of the class, but there's about 2 minutes left, so I don't suppose I will. Right, okay.